Cholesterol is a unique sterol and is essential for at least 4 distinct cellular functions. Cholesterol is needed for the synthesis of bile acids and bile salts, which are needed for emulsification of dietary lipids, digestion, and uptake. Cholesterol is needed for membrane synthesis and for the maintenance of membrane fluidity. Cholesterol is the precursor for the synthesis of vitamin D. And cholesterol is the precursor for the synthesis of all steroid hormones, including cortisol, androgens, and estrogens. Cholesterol biosynthesis occurs through a completely different pathway than fatty acid biosynthesis. It occurs in 3 stages, with the first stage being the most important one because it contains the rate-limiting enzyme HMG CoA reductase. This enzyme is tightly regulated by hormones and intracellular levels of cholesterol. Isopentenyl pyrophosphate formed from mevalonic acid will be sequentially added until squalene is formed, and then squalene is cyclized to form lanosterol and then cholesterol. It is noteworthy that acetyl-CoA needed for cholesterol biosynthesis is produced by hydrolysis of citrate by ATP citrate lyase in the cytoplasm. Cholesterol is probably the most important regulator of its own synthesis through its regulation of HMG CoA reductase. It can do that in at least 3 distinct ways. The first one being a feedback inhibitor of the enzyme. The second one is to change the gene expression of the enzyme, upregulating or downregulating the amount of enzyme made in the liver. And the third one is promoting proteolytic cleavage of the enzyme by the proteasome